Hello everyone, in this video I'm going to show you how to solve the SFD and BMD problem with the help of Ansys. So this is the cantilever beam which is loaded as shown in figure, and it is having the cross section of 0.5 meter into 0.5 meter. Okay, so first I'll go to Ansys, where I'll go to preferences. I'll set it to structural and I'll click OK. Then I'll go to preprocessor element type and I'll add the element type, that is beam 2 node 188 element. I'll click OK. Then I'll have to give the material properties, and the material properties here, that is the Young's modulus and Poisson's ratio of steel, which are 2.1 into 10 raised to 11 Newton per meter square and 0.3 respectively. And I'll click on OK. After this, I'll go to the section of the beam, where I'll mention the sections of the beam as 0.5 meter into 0.5 meter as shown in the problem. The width is 0.5 meter, the height also is 0.5 meter. Then I'll click on OK. Yeah. After this, I'll have to create the key points, and here I will create the 4 key points. So first let me start by creating the key point, and in active CS the first key point will be at 0, 0, 0, and then the second key point will be at 1 meter 0, 0, the third key point at 3 meter, and the fourth key point at 4 meter. Okay, so these are the 4 key points which I've created. Now I will have to join these key points with the help of straight lines. I'll create lines, and I'll join the key points with the help of these lines, as I'm doing right now. Okay, so these are the lines which I have created. After this, I'll go on meshing this geometrical model. So first I'll click on meshing, then mesh tool, and first let me do the size control, where I'll give the manual size. All lines, the element divisions, I'll make some, let's say 5 divisions per line maybe. Yeah, I'm making 5 divisions per line, or basically 5 elements per line, and then I'll mesh the lines. I'll simply click on mesh, and then then after this I'll have to go to solutions, where I'm going to define the loads. So first I'll fix the leftmost node or leftmost key point, and I'll fix it with respect to all degree of freedom, because the left end of the cantilever is fixed. Okay, then after that I'll have to go on applying the loads. First I will apply the point load on the end key point. And how much is that point load? It's acting in the y direction, and it has the magnitude of 30 kilonewton. Yeah, and since it's in negative y direction, I'll have to mention minus 30,000. So next, yeah, so this is how the key points will be visible, so that the applying loads will be quite easier for me. Now I'll be applying the UDL, which is in the middle. For that, I'm applying the pressure load, because I can't apply the point load on the lines. Here it's UDL. So here, this is the technique that I'm going to apply the UDL load here. Okay, so it is the lines, and per line I have made 5 elements, and I've selected those elements. Okay, and now I'm applying the pressure on these beams. Okay, and here. So what will be the pressure value? Pressure value will be uniform. I'll simply randomly give it a load key. Pressure value at node I will be, yes, it'll be 10 kilonewton, and same will be at J because it's UDL, that is uniformly distributed load, and this is how the UDL is applied on the line. Okay, and once the UDL is applied, I'll just simply give the solve command to solve the problem, and the solution is done. Only thing is I need to extract the solution with the help of general post processor, and the solution here will be the SFD and BMD diagrams. So I'll have to build an element table to extract SFD and BMD. So I'll go to element table, then define table. I'll go to add by sequence number and SMISC 3, and again I'll go to by sequence number, then SMISC 16. Okay, and then I'll again go for by sequence number, and this time I'll go for SMISC 6, and then again I'll go for SMISC 19. Okay, so I'll close this for now, and then I'll go to plot result, or basically plot results, and go to line element result. So for SFD I'll take SMIC 6 and SMIC 19, and this is the SFD that I will get. Okay. So this is the SFD that I will get for this particular problem. Yeah. Yes. And then to extract the BMD, I'll have to choose the rest of the two values, that is SMIC 3 and SMIC 16, and if I click OK, this is the BMD that I will get. Okay, this is the BMD that I will get. Yeah, this is the BMD. So this is how to extract the SFDs and BMDs of any beam problem with the help of Ansys. Okay. Thank you, people.